So welcome to this workshop. So we like to do things a little bit different. So this is a workshop session. So if you have your laptops, that's why Ahmed was asking to connect to the Wi-Fi. It's meant for you to have hands-on experience annotating data. So the workshop is automating data annotation with MicroModels. I'm JF, I'm from Sama, and I'll be your host today. Why did we set up as a workshop? Is because we believe the annotation process is interactive. It needs to be the interaction between the human and the computer that's at the center of this process. And this takes form in two aspects. First, as a data scientist or machine learning engineer, you want to stay close to your data. We saw everything about data-centric AI, and we're fully on to that as well. So having access to your platform and being able to annotate a few images or videos or what have you of your data is a really key aspect of getting familiar with the annotation and lends you better result in production. The second aspect is from the annotators themselves. We believe the annotators need to be really close and work really well with the machine. And we'll see a bit more about this and what we do with our micromodels at Sama. So the workshop is structured like this. I'll probably talk about 15 minutes. Then we'll do this interactive demo. And we can have some time for Q&A at the end. But just to get everyone set up, we have three ways for you to participate today. One is if you go to our website, you can find this free trial, Sama Go free trial, and you'll be able to register. This will allow you to participate later on as we get to the interactive part. The second way to do this is the brochure that were distributed to a lot of the tables here. And if you don't have a brochure, maybe raise your hand and we can get you one. Guillaume, can you? Okay, thanks. So we have one there. So if you have your laptops and you have your brochure, you'll be able to access our very own platform for annotation, and you'll be able to do this with us today. So if we talk about Sama a little bit, Sama is the training data platform trusted to develop accurate machine learning models by the world's most ambitious AI teams. We have a list of logos here, and some of them have been with us for over 10 years. But rather than speak about those in detail, I'll just show you a quick promo video. Okay, good. So what you saw in the video is Sama offers a wide range of data annotation offering. We go for 3D LiDAR, sensor fusion. We do some polygons and bounding boxes on images and raster mask, and we do object tracking in videos. All of this has ML power, and most importantly, as the topic of this talk today, we favor the human in the loop to always hit the highest quality in the industry. Of course, without API, we wouldn't do this at scale, so APIs are very important here. We have corporate offices here in the Valley, in Costa Rica and the Netherlands, and in Montreal, Canada, where actually I come from. But most importantly, we have our own delivery center in Kenya and Uganda, where it all started for Sama 14 years ago. So Sama was founded as by our late founder, Leila Jaina, with the idea and the strong belief that if you give work to people in underprivileged situation, it's a better way to lift them out of the cycle of poverty. We have, since last year, a B Corp certification to attest to the impact that we have on the lives of these people. And it's also a differentiator for our company because as most or a lot of different players in the industry will go with crowdsource offering, we prefer to have them as full-time employees. Having them as full-time employees means that they become expert in our tools. So the tools you'll be able to experience today, we have them train and learn how to use them to be at the most efficient possible. And we also put forward what we call human-centric design. So we ask them their feedback when we design new tools, and we work with them to actually have their feedback on how the tool would be best used and what new features they would be looking for. So the human is really at the center of our design and how we look at our features. It also means that they become experts in our clients' requirements. And one of the tricky part of doing data annotation at scale, it's to figure out the right requirements and have a workforce that's able to apply this consistently across your data set. So having these full-time employees be expert, one, on our tools, and two, on our clients' requirements is really a key to deliver the quality that we deliver. But let's talk a little bit about AI. So without data, there's no AI. We have this simple slide that reinforces the idea of data-centric AI, where 80% of the effort is actually spent on the data collection, the data preparation, the analysis, the filtering, everything you do to label your data, all before you feed that to your training model. Then you train, you figure out which model to use, you optimize the results, and then you want to go back in this loop and train and collect and label more data. And that's the virtuous circle that we're looking for. And that's where most of the effort is spent on the data itself. We do this for many different industries. I don't have to go over all the use cases. We saw plenty of them already today. But like self-driving cars, virtual try-ons, and frictionless checkouts, and everything you can do in media and smart hardware, we have offerings for all of these. Now, our ML-assisted annotation, what we call our MicroModels. If we start from the beginning, when you're looking at an image like this and you want to do the annotation for object or scene segmentation, you have to realize that your task is to do the contour or a polygon around each of these objects, whether they're cars or motorcycles or pedestrians, or you have to draw a mask on a category of objects like the street here or other, like the trees. And this is really time-consuming. Manually doing this at scale for every image, for every task, it takes a lot of time. So that's where ML comes in. We train our ML models to recognize these objects, whether it's the plates or the mugs or the cups that you see on this image or any of the other use cases. We train our ML models to recognize them, And then we always have the human in the loop to give feedback as to the quality of the annotation, fix what we didn't get exactly right with the ML, and apply this on our client data. These methods work really well in academia, but when you look at them in production, it becomes really tricky to hit the really high threshold of quality that we're aiming for. So let's look a little bit at the techniques. So the definition of our MicroModels approach is an architecture that allows us to expedite the labeling process by drawing on a library of models trained on a specific use cases. So basically what we're saying here is that it's really hard to hit the level, it's almost impossible to hit the level of quality that we're aiming for with one generic model across all classes, across all tasks, across all kinds of images. So we favor an approach where we have a base model, but then we fine-tune it on specific classes or specific data so that it becomes a lot more accurate on this specific set of data, and we're able to do that with higher accuracy and higher quality. Failing that, what happens is that our annotators, if for say, your model only outputs 50% AP, which is common in academic data set, our annotators will end up redoing the annotations from scratch rather than taking advantage of the ML because the ML was not accurate enough to help them save time. So how does it work? The technique we have here today is few-click annotation. It comes from a paper published in 2018 that has a nickname of Dexter. And basically, you want to segment this car here. So you'll do 4 clicks. The 4 clicks are really critical to the model in understanding what it's looking at. So you want to click on the extreme left, extreme right, extreme top, and extreme bottom pixels of these objects. And that's going to generate a heat map that allows us to draw a raster mask, and we, in turn, convert that into a raster, into a polygon to mimic the user input that would be if they had drawn it manually. As a sample results, what you see here on this toy data set is the top row where the ML did not play any role. The annotator went and did it manually. And the bottom row where we compare what did the model predict. And once we have these predictions, what we look at is the IOU, so the level at which the two polygons overlap to see if the prediction was accurate or not. And we monitor this IOU to see how our performance of our model looks like. This old technique allows us to have, in production, 94, 98% accuracy on specific use cases. It allows our annotators to save 2 to 4 times the efficiency on the annotation process, but most importantly, it allows us to deliver for our clients quality data in production much faster. Okay, I'll start with the interactive demo. So let's just see by show of hand, are you guys all set up with the platform, the logins and whatnot? Has everyone had time to either register or it doesn't work. It's not intended for phones, so only for people with laptops. Sorry about that. It's really tricky to do large annotation on a phone, so maybe someday, but we're not there yet. Okay, so Samago. Let's just, before I get into the interactive portion, Samago is an alpha release that we did 2 weeks ago, so it's brand new. It's the self-service platform that we have now at Sama to enable machine learning engineers and data scientists to get access to the setting up their project, doing a few annotations, and then what happens is as they upload their data, customize the instructions, they're able to figure out what should we tell the annotators to do by doing a few of them themselves. And then we have this boost button where you have the power of all our workforce behind it if you want to scale. So it allows you to start slowly and easily, and then you can scale your project. Good. So this is the dashboard you should be landing on if you have followed the login process. Don't worry if you don't. I'll be doing everything on screen. It's just more fun if you want to participate in, but you're not losing anything if you don't. I'll be doing everything on the screen so you can all watch. Okay, so here we are. I'll just get that. That's going to be easier. So here we are in the dashboard of Samago. What you can do in Samago is click on New Project and define your own projects, instructions, and whatnot. And we have a few demo projects for you to look at. And what we'll be doing today is annotate the COCO data set with the machine learning assisted annotation technology that I've been talking about. So if you want to click on this demo project that says annotate the COCO data set, that's where we'll do the interactive portion. So I assume by being at the Computer Vision Summit, everyone's already familiar with COCO, but just in case, COCO is a benchmark data set that was published in 2014 with over 100,000 images of common objects in context, meant to be recognizable by a 4 or 6-year-old. I'm not sure which one. I forget. Basically, it has a lot of really tricky images, and that's, if I just step away really quickly, that's what I was referring to. If you go to their official website and you look at the leaderboard for segmentation, you see that even after all those years, the best AI teams in the world have achieved 53% in AP. So it's really tricky to do COCO well and to do it at scale, and that's why I emphasize on the micromodel approach where we don't try to do all the classes at once. We try to segment and have specific models trained on specific classes to be able to hit that quality and that accuracy I've been referring to. So here we have a few images of COCO within our platform. And what I'll do first is I'll draw a polygon manually. So you have this polygon tool here. I can zoom in with the mouse wheel. And I can, let's say, take this donut. My preference is double chocolate, so I'll start with the one that I prefer. I'll be clicking all around this donut. And if you've never seen data annotation at play before, that's how things are done when they're done manually. You end up clicking every single point around the polygon, and then when you want to finish your polygon, you double click. This gives you on the right the category, so you have to identify what class it belongs to. So this, we will scroll down and find a donut class and click on this. And so we have one shape done. Imagine having to do all of these donuts as your day-to-day task. That's what our annotators do. So what we try to do, as I explained, is try to make their life easier. So what we'll do now is we'll look at how to do this with our machine learning. So if you go back to the polygon tool, but you click on the one on the right with the small lightning, Now we'll do the 4 clicks. So let's take any donut, like let's say this one. We do 4 clicks. It's important to remember you want to click on the extreme left, extreme top, extreme right, and extreme bottom pixel of these donuts. And you get your ML prediction. And I'm pretty happy with this results. Maybe someone in the food industry would like 1 pixel here or there, but I think that's pretty good. So I'll label this as a donut. And then I'll pick another one, anyone, like let's say this one. It seems tricky. And that's where edge cases and things like that come into play. So we'll try one that has occlusion, that has like, you see the pixelated images because they're from 2014. So everything about cocoa varies a lot, and that's the prediction we get. So again, doing the 4 clicks, top, left, right, and bottom, I get my prediction, and I get to select in the list the donut as a class. So of course, for the purpose of this demo, I won't label all of these. That would take way too much time. So let's just say that I have those 3 donuts. Is everyone able to follow so far? I just don't want to go too fast. Okay, so what I'll do now is scroll down on the screen and submit this answer. And this will move on to the next image. Now we have apples and bananas. Again, we could do the manual, but you get the idea. So let's go with the AI. We zoom into this apple, and this one is dead center, so it should be pretty easy for the model to recognize it. Really, really accurate polygon. I'll tag it as an apple. Now, I'll use a much trickier, so this apple behind it is maybe 1/3 visible. I can still click on the left, top, right, and you see the crosshair in red. That's to help you figure out where your bottom and extreme pixels are located. If I click on this one last time, I get, again, it's not perfect. There is a little bit of overlap, but I'm pretty satisfied with this, given that it's almost like 2/3 occluded. I think I'm getting a good result. I can look at this banana now, and let's do, again, the same 4 clicks. So I'll have the left, the top. I'll zoom in to do the right and the bottom pixel of the banana. And I see I get a really nice polygon of a banana. So now it's time to get a little bit picky and say that we want to edit this polygon because it's not quite as accurate as we want. So we can zoom in, we can select the edit tool, and we can add some points here to add to the accuracy. Or we can hover on these points and move them so that they're more aligned with what we want to do. And once we're satisfied, we tag this as a banana. All good so far? Cool. So once again, I won't do more than 3 objects for this image. It would take too much time. So I'll
JF,
yes.
just one question.
People cannot log in. It asks for 6-digit character from Google.
Oh, let me go back. For those who used this brochure with the credential on the brochure, when you get to this screen here, you want to click on, sorry, I'll try to make this bigger, just the beauty of a demo. Okay, sorry. Basically, down here, there's a recovery code. So you want to click on the recovery code link and enter the recovery code that's on the brochure rather than the 6-digit. So we did this to bypass the two-factor authentication for the purpose of the session today. If you log in properly, register properly with our usual means, you'll get the full onboarding experience. You'll get to acknowledge our terms and conditions and whatnot, and you'll be able to live the exact same experience. We just wanted to speed things up today by doing this with a few accounts that are on the brochure. So is everyone okay for us to continue? Thank you for asking. It's something I skipped. So now we have this. So we'll go to the next image. And here we get to a really tricky image of spoons and forks. And just for disclosure, this one we did not fine-tune on these classes. So you'll see that when you do your 4 clicks on these, let's just take this spoon. It's not as accurate as I saw from the apples and the bananas and the donuts before. There is some like adjustment that we need to do. And again, that's because we want to guarantee the highest level of accuracy. If you look at original Cocoa and how it was annotated back in the day, this would have been fine and they would have just leave it at that. But we want to go even further and increase the accuracy. And so that's why we have this ability to edit, and the model we want to train is not going to be a model that's as accurate on this one specifically. Let's take a fork. We see how pixelated the image is, and as I do the 4 clicks, I get something good, but it's not pixel perfect. So I might want to edit that and make it even better. We'll just have to find a fork. And now let's try this book at the back. So just random 4 clicks of the extreme pixels of an object, and we get a nice book. So basically what you see here, and you're probably trying it yourselves and not using the same exact objects that I'm targeting when I'm doing it, and maybe you don't get the exact same results as well. The goal of this is to be interactive, is to show you that with the help of ML, we can do some improvements, some gain in efficiency, some accuracy, but we always need the annotator to review this prediction, to go and do it manually and edit, and if we want to bring it to 95, 98% accuracy, we need this human interaction. So that's the main thing we want to talk about here. Let's look, there's 2 more images, I think. I chose this one because it's really tricky to figure out where the broccolis start and when they end. So I can click on my 4 clicks. I assume this is the broccoli here. And the model, again, performs pretty well for my liking. And then I'll do this one here. It's tricky because I don't know without the crosshair where is the left, where is the right. So I'll tag it here, and I'll assume this is the bottom. And here you see that it left out a portion of the broccoli. So now we also have intelligent edit mode, where if I select this lightning here, I take a point that's on the current boundary and I drag it. It will redo the prediction and improve the quality of the prediction. It does not work on all objects, on all classes all the time, but when it does, it's really useful. So that's going back to what I was saying, why RML does not work across the board or anything, but we have the luxury, if I may, to have expert annotators that learn to use these models, that get really good. They're the experts of this, of using this, so they get to gain this efficiency that we see here by learning how to use the models, how to use the tools that are available, and doing these annotation for several images. Okay, so enough with the broccolis. Okay, so one note, if you're doing this and you forgot to tag, it won't let you submit your answer. You need to always make sure that that's what I did here, almost on purpose. I forgot to tag it, so if I don't give it a label, it won't let me go forward to the next. So if anyone forgot that, that's something I wanted to mention. If we're satisfied with the broccolis, let's go to the last image.
Question.
Yes.
So we see some of your images are pixelated,
Yes.
and that negatively impacts masking process.
Yes.
So I want to know if that's the shortcoming from your application side or a more high resolution image can be annotated more perfectly using your application.
Yes. So Coco was annotated and all images were selected back in 2014. So images from back then, we see, like that's why Coco is famous as a benchmark, is because it's been established as one of the way for ML engineers to compare their results against other models on a fair apples-to-apple comparison. But it comes with this long tail of images that are either blurry, super crowded, super noisy, or super pixelated, like we saw. And so what we have here is a model trained as a baseline on these data. So it learned to recognize that there's pixels, and it learned from the, let's say, annotation of 2014. So not all of them were of the highest quality, not all of them were on high-res images. So the model learned from that. And everyone that trains or pre-trains a model on Coco these days suffers from the same. So if we had an equivalent model, what we do when we have high-res images is we might leverage the baseline of Coco, or we might say, forget it and start from scratch and train a dedicated model for the use case at hand. Okay, so we're down to the last image, so I'll be able to take more questions before it's over. If you want to interfere, like, just raise your hand and we can start taking some questions. This is the last image that I have as the demo. And just to show that what I was saying, images in Coco can get really tricky. How long would you think that it takes for an annotators to individually segment each of the relevant object in an image like this? It takes hours. So by having the model help, we know, for example, backpack is one of the classes it was trained on in Coco. So we can do backpacks and tag it as such. We can do umbrellas. And again, we tag it as such. And then we want to do, let's say, the person here. And this is when it gets tricky, because you have to figure out the left is easy, the top is easy, but you need the crosshair to figure out, okay, I think she's holding a cell phone in her hand, so the right pixel will be on her foot rather than on her hand. And the bottom pixel will be here. And I get a pretty decent person prediction. I can come in and try to move a few of these pixels. I can click options to erase or delete one of the points. And doing it like this, I get the person annotated, PPP person. There we go. And then I want to do the car that's hidden behind these people. So here, I'll do part of the car. So I won't do the entire car, but I'll still try to cover most of it. And that's where you see that the prediction is not perfect. And I want to go edit. So I can either edit with the intelligent edit mode here, or I can take my manual edit, I can zoom in, and I can say that the windshield stops here rather than where it was before. Now I have this occlusion issue, so what our platform allows you to do, if I just tag this as a car, is come here and drag this so that the layering is changed. And now the car is behind these other objects. And if I increase the opacity and hide the occluded shapes, I can see that the car is hidden by these other objects, and we get the nice polygon as a result. This was the extent of the interactive demo. I'm happy to take questions and go over some crazy use case you might think of.
Very good. Thank you. I assume people have some questions.
I saw one in the back.
Okay, some crazy example.
And Tim,
So
next one is here.
thank you for the presentation. In the case of the car, if I feed, am I able to feed the machine learning, this recognizing the car, going into a library, bringing the dimensions, and filling up the rest based on the perspective? Meaning that it recognizes this is a car, it recognizes it's a limo or Buick or etc.
Mm-hmm.
It goes into a library, it looks for the dimension, checks the dimension against the top, bottom, or what it sees, and then completes the car. And it's able to actually put it in 3D perspective if it has the whole dimension.
This is not meant to be for 3D. So Coco is a pure image task where you do objects segmentation or bounding boxes around objects. This is not meant as a 3D use case. So what you'll see here is the model learns to recognize objects that are, like if I just open this up, if we're not familiar with Coco, Coco has 90 different classes that are common classes for people to recognize. So it will learn, if we train a baseline model on Coco, it will learn to recognize these 90 classes, but it will do much better on some classes that have more examples and less accurately on classes that are fewer examples or more trickier examples. Yeah.
So my question, even with 2D, if I tell it this is the make and model, and it learns, so instead of put like broccoli, I put Buick, Chevelle, or etc. And then for those, it learns the dimensions, and then it fills automatically and completes, no matter how small part of it sees. Once it sees it, it's going to bring in and scale the dimensions to the rest of the car. So it actually learns to automatically, because you're feeding it the original all the time, it becomes like an additional library, and then because you're feeding it more detailed specificity, you know, of what it is, it's gonna actually start recognizing the rest of it by itself over time.
Yes. So,
for any car.
Yes. So basically, Coco is used as a baseline model, as a baseline data set for a lot of applications. What you describe here, from what I understand, is you could start with a base model that learns the basic attributes of a car compared to a person or a dog or something else. And then you would want to fine-tune or build a second model or fine-tune your model on these classes or these attributes. So that's where you would get the better accuracy with the fine-tuning on specific use cases and specific classes or attributes metadata.
Okay.
He already has a mic.
So why 4 points? Seems like you may benefit from, like for that car, maybe 5, 6 points can help with a more complicated shape.
Yes. So thanks for the question. So the few-click annotation comes in different ways of implementation. The model we'll rely on, I said earlier, is Dexter, was published in 2018, is a model that starts with 4 clicks. It uses those 4 clicks as a heat map to know where to look. There are other models that exist that will use a bounding box as the input, or that will use a bounding box plus a click in the middle as additional information for you to know what you're looking for. So we start with 4 clicks. This is one example of a model that I wanted to show today. And then if you see here, this intelligent edit, it allows you to add a 5th, a 6th, or a 7th click. So you always start with 4, and automatically we try to predict something. And then if you find that there's a large portion of the object that needs to be included or excluded, you can use the intelligent edit. If you find that you only have like very small edits to do, you'll go manual. And that's all part of what we train our users to understand about the model. The relationship between the ML and the human is the key, and how we train them to use that and leverage the power of the tool the way it's designed.